Once the trucks leave their logging operation, they drive across the country roads at 45 miles per hour until they arrive at the delivery mill. In the base model, the desired delivery mill was chosen randomly. It could be koala paper, bright, and papertech. The probability for each mill to be chosen was affected by the priority that the mill had. The priority of the mills was higher or lower depending on the quantity of their inventory. If the mills raised their priority, they receive a 1 million penalty, but the wood trucks will be choosing the mill more often, so their inventory will rise faster. The priority of each mill will be increased only when their inventory drops below 20,000 tons. When the trucks arrive to the mill, they are weighed on the scale house and are weighed again when they leave. We assume the weight of the wood since the entrance of the truck and from that point calculate the delivery costs. After the truck entered to the mill, they will slow down their speed to a maximum of 10 miles per hour until they arrive to the offloading area where they will be choosing one out of 6 crawlers to be attended. The crawler will take 10 minutes to perform the offload. Then the crawler will take the wood to the storage house. Until the wood is in the storage house, the inventory will be updated. Each crawler has a dedicated state variable where it will be stored the amount of time the crawler has worked. This is used to control when a crawler has accomplished more than 250 hours of work. When this happens, the crawler will be disabled due to maintenance work. It can be disabled from 1 to 5 days. 98% of the time, it will be just 1 day. Each day, the mill has the probability to reduce a certain amount of paper, based on a random distribution. This amount is defined at the beginning of each day with a process. The digester is always working 24/7. At the beginning of each day, it's also verified if a stockout or an inventory drop below the 20,000 tons has occurred in each mill's inventory. If a stockout ever occurs, there is a process that stops the digester and can only be reactivated when the amount of inventory is over 1,000 tons. The delivery costs of each mill are calculated on the scale house and storage on a state variable. For the average inventory, on each mill we measure it at the end of each day. The total inventory holding cost was measured with the WACC of 6% and a price of wood of $50 per ton. In the base model occur a lot of stockouts and penalties, and many days of production were lost. What we noticed was that the priority method for the delivery wasn't very helpful, and the time travel between the forest logging operations and the mills took a lot of time. Here in the definitions area, we got all the state variables that we needed to make the model work. The state variables for the weather conditions, for the inventory, for the penalties. And here in the process area, we got processes for the digester, for each mill where it decides if any stockouts ever occur, and then waits until the inventory is reestablished. Here are processes for the calculation of the average inventory, a process to calculate the transportation costs, the daily production of paper, and the maximum capacity of each mill's inventory. All of these are the processes that we used to calculate the work hours of each crawler and their maintenance procedure.
I'm gonna be explaining the login operations. Well, first of all, we got our source where we create our trucks. You can see that in arrival mode, we got on event. Initial number of entities were creating 4 to 6 trucks per login operation. And in events, the triggering, we got a sync. This sync just will execute the triggering one time because it's not connected to anything. Second, for mounting the load of goods to the transports, in this case the trucks, we got a combiner. In this combiner, we had the capacity of 1. Just for one load of food, it's allowing in one truck. For the speed, we got a transfer node. This transfer node, we change our state variable. In this case, desired speed to 45, that it's the speed, maximum speed, that the truck will hit when it's loaded. Last but not least, we got our source where we create our lots of wood. So, first of all, we have the state assignments in before exiting source where our model entity is changed to priority. This priority will save the weight of the lots of the wood. In this case, we'll assign the weight with a random triangular distribution with minimum of 25, mode of 30, and maximum of 35. Second, in add-on process triggers, we got in creating entities a process called creación. Well, this process first we decide the hour of the simulation. In this case, our login operation is just gonna work from 7 a.m. to the 5 p.m. for 17 hours. In the case that the number is not in these values, the hour, we will assign the quantity of the creation of the wood to 0. So, like you can see, in the source we got candidate 2. In this case, we're saying that even if the process is running and creating lots of wood, it will create 0 lots of wood. So second, we define the day. If the day has changed, we will run all these tasks or works in our process. Here we're going to assign the date that we are working for comparing with this decide. Then we will choose, we will compare the date of the simulation. This day is the first one, that is Monday. We will assign cantidad 1 to 0. So all the sources that got cantidad 1 will not be working. If it's Tuesday, we will assign to cantidad 2 0. So all the login operations with the cantidad 2 in entities per arrival will not produce any lots of wood because they will be in maintenance of the trucks, and so long. With cantidad 3, 4, 5, 6, or in the case of Sunday, 7. After deciding which day of the week will each login operation still working, we will decide in which time of the month, in which month simulation is running. This is for checking out the ground condition in the simulation. So first of all, we decide in which month we are with daily time mount timeout. So in this case is less or equal to 3. This meaning that if we are in January, February or March, we will choose a set of variables to define how many lots of wood we are going to create in these days of the month. So in this case, this one will be for the frozen days in the ground condition. The second one is April and May. It's going to define the behavior of our simulations when the ground condition is soft, but the soft day we got the chances to be a muddy condition in the ground. So This is about the 5%. So for this, on the site type, I choose probably base. So if it's 5%, we got our quantity of wood created to 0, and we got a mal clima named variable. This variable will work to deploy the number of days that the simulation cannot run because of the bad weather or bad ground condition. And last, we got our dry condition in the ground. How we use the variables that we change in the process in our source of lot of wood. So, as you can see, in interval times, we had a random uniform distribution where we decide the time that takes to create a lot of wood. We got two variables here, or two state variables, minimum variable and maximum variable. In the process, depending on the ground condition, we modify these variables. So it will use the parameters in that the project gives us. So, like you can see, we're changing the minimum variable, the maximum variable, depending of the weather and the ground condition. Second of all, we got entities per variable, in this case, cantidad. This will allow us to not generating any lot of wood depending on certain conditions, like the date because there is maintenance, or is the ground condition moody. This is all that we got in the login operation. Uh, I was forgetting something. The process creation is just necessary to having in one source creation. It's not necessary to have it in all of the source creation because this just use these variables that we change in our process. Like you can see right here, we change the entities per variable to cantidad 3. It will rest the days Wednesday.
This solution we propose is the segment, the logging operation, the supply, the paper milks. The 100 logging operation we distributed in the 3 paper mills. 36 cutting operation for koala paper and 3 true cutting operation for paper tech and 3 and 32 operation for brief. In this way, we eliminate the fines in each mill, and the priority for deliveries is eliminated, since each mill has a set of logging operations that supply in which wall. In order for mix to always supply timber, we assign each logging sector 1 day of rest per week, so that they are always working for the purpose of the 32 logging operation. The rest days were divided as follows: for logging operation rest of Monday, and for loading operation declined Thursday until all loading of options rest of different days so that there is always a supply to each meal. The one question: what is the total transportation cost for the system? An initial model koala paper this results, and the optimization model koala paper this results. What is the total cost of improvement for the system including inventory and transportation? The negative values mean the under the cost, and the positive number mean that there was an increase. What other improvements to the system can you recommend? Subcontracting each coding operation detailed exclusive with supplier a paper model. Subcontracting each coding operation today exclusively with supplier a paper model. Try have the coding operation try work in the Nestor Forester to paper milk. Reduce the number of activated lorries per load. That there is always more than one truck waiting for the load of wool, so would be lorry at rest, wasting time. Occur and the extra register for the season where more wool is produced to shoulder advanced maintenance days for the coring operation so that at least one coring operation on all days of the week to supply all the paper mills.